Good afternoon, everybody. We're going to get started. Thank you so much for being here. So we got kind of got a packed room. I'm sure that's mostly because it's hot outside and you just wanted air conditioning. But I'll pretend it's because of me and Solana, just to feel better about myself. Cool? All right. I'm really excited to be here, talk a little bit about Web3 and Solana generally. Web3 is still so new, right? So much so that very few people can claim to be experts. I certainly am not an expert myself, which makes me that much more excited. We're kind of all in this together. unless you happen to be an expert, in which case maybe you're up there and the rest of us are back here. But anyway, regardless of your development background, there's a space for you to jump into Solana. There's a bunch of different entry points as far as development goes, and that's one of my favorite things about the network. Just a little bit about my background. I started out developing as an iOS developer, so very different from what we're doing today, from what you would do in program development on Solana, but still figuring it out, which means that it's possible regardless of, like I said, what your background is. Today's workshop is going to be pretty basic and front-end focused, but hopefully it gets you a little bit familiar with working with Solana, so you can kind of see where the path to moving forward is. Before we jump in, can I just get a quick raise of hands? How many of you have done any kind of Solana development? We got a couple. Okay, cool. How about used Solana as a user? Okay. Hopefully have like a wallet installed, that kind of thing. Awesome. All right. So this is what I got planned for us today. We'll do a very quick, very high level, very oversimplified overview of Solana and its structure. And then we'll do a mini dive into transactions, talk about what they are, how we use them, right? And then finally, we'll build out a small part of a movie review web application, and we'll do that all together. A couple of thoughts, though, before we actually jump in, is first, I'm going to assume that most of you are, or at least are familiar with front-end development, okay? Mostly React and TypeScript. Now, if you're not, that's okay. Don't leave. Don't have to scare you off, right? Like I said, I'm not really a front-end web developer myself. My background is iOS development, and yet I'm here making it work so you can too. All right. Next, I'm also assuming that you're brand new to Solana development. So for those of you who raise your hand saying you've done Solana development before, you might know some of these concepts already. Again, before you rush for the door, I'd love for you to stick around and act almost as like a TA during that portion where we're working through the project together. If the people around you are less familiar with the concepts and need some help, please help me out, right? Like that's what's great about this community. And then lastly, for those of you that aren't familiar with Solana development, maybe you're less familiar with development in general, or you're very front-end focused, some of this stuff can get pretty low level. And I want you to, I know that can feel scary, right? Like I know when I'm talking about byte arrays and that sort of thing, it can feel a little bit intimidating. I want you to know that you can do this. It'll be okay. The more you work with it, the more familiar it'll feel, the better it'll be. Okay, and I'll do my best to help explain things. And we got a bunch of great people in this room who can also help out. Also, as a side note, everything we cover today exists in an open source course that you can find at the link there, soldev.app/course. I've got a team that's been working with me to build that, and we've got some pretty great content up. And we keep publishing every few weeks. So the goal is to basically have just the greatest onboarding experience to Web3 development possible, and that's what we're working for. All right. With that, I mentioned that later we're going to be building a project together, or at least part of a project. So I've got a starter repo already set up. There's a QR code here if you want to get it that way, or you can go to that link. It's a lot to type, which is why I put the QR code up there. When we get to that point, I'd love for you to follow along if you're all comfortable with JavaScript or TypeScript and React. If you're not familiar with React or TypeScript at all, you know, it may actually be best for you to just watch and try to glean the concepts as opposed to following along. But only you can make that decision. So you know how you learn best. I would refer to you and your judgment. But if you want to follow along, I'd go ahead and download this now, just to make sure it's ready when we get to that point in a few minutes. Cool? I'll leave it up for like another 15, 20 seconds to make sure everyone had an opportunity to download it if they want the opportunity. All right, we good to move off of this slide? Anyone need an extra minute to get this link? Okay, I'm gonna go ahead. All right, So let's jump in. This is a simple diagram of sort of how Solana works at a high level, right? You've got programs, which are typically written in Rust, that you deploy to the network. And then you interact with those programs and accounts through what's called the Json Rpc API. This is probably a drastic oversimplification, but the Json Rpc API is effectively just an HTTP post where the body of the post is JSON that represents the methods you want to call on the API. So if you want to get a list of accounts, right, you have JSON in the post call that sort of identify that that's what you're doing, and obviously it's got to match the formatting that the API expects, but it's fairly similar to most REST APIs. RPC stands for Remote Procedure Call. If you're curious, probably doesn't matter, but if anyone ever asks, remote procedure. Now a little bit about the implementation within the network. So that piece off to the right there, right? Data on the network is stored in accounts. You can think of accounts like files, okay? So just files like you would in the normal Linux type operating system. Even programs are just stored in accounts that are marked as executable, okay? And depending on who you talk to, you may hear people call programs smart contracts. Okay, so depending, if you're coming from Ethereum, you might be working on Solana and call it smart contracts just because that's what you're familiar with. But you also might hear people say programs, and what they're referring to is the smart contract equivalent on Solana. Good so far? Awesome. All right. Now, you don't modify account data directly in Solana. Instead, any data writes happen through what are called transactions. Again, if you're familiar with blockchain development on other chains, it's probably pretty similar, right? So data writes happen through transactions. Effectively, transactions are just program calls. Okay, so we're just calling a function on a program, essentially, when we submit a transaction. Working with transactions can be tricky, so I'm going to leave it at that for now, and we're going to circle back after the overview and actually spend most of today talking about transactions and how to submit them and actually do it for real using a JavaScript library. Network queries are a little bit simpler, but they also happen through the Json Rpc, and they're not too bad, but they still come with a bit of boilerplate. So, for example, this is sort of a TypeScript example of what it might look like to get the balance of an account on Solana using Json Rpc. Pretty extensive boilerplate, right? It's like no one wants that. In the same way that you probably don't use fetch directly in all of your code, you write a method that abstracts that, right? So you can say, give me this stuff, and then it takes care of it. Similarly, you don't have to actually do that. You can use what's called the Solana Web 3 libraries. Okay, has a lot of really useful abstractions. Makes it so you can call Json Rpc methods natively from JavaScript or TypeScript. And there are libraries like this for a bunch of different languages. So whether you're working with JavaScript or whether you're working with Python, there's probably a library you can use. We'll be using the the JS library today, just because one, that's what I'm most familiar with, and two, that tends to be what most people in the community use. So, any questions so far? All good. Okay, let's dig into transactions. How many people recognize this image? Got a few. If you've ever used Solana or really any other blockchain, you probably recognize it, right? It's just a pop-up from a browser extension wallet, okay? So a wallet that stores your secret key, and this is basically used to sign transactions on behalf, well, for you, the user, without exposing your public key or your private key to a website, okay? Now in this scenario, the website decided what was the information that was going to be packaged up into the transaction, and then submitted it to your wallet for approval. So we're going to talk about the rest of this time is if you, the developer, are making the website, what information are you gathering, packaging up into that transaction, and then submitting to a wallet, okay? So let's talk about transactions and their contents on Solana. A transaction contains an array of all accounts it intends to read from or write to. That's fairly unique, I think. And let's talk about why. Does anyone have a guess? One of the non-Solana developers in the group. Anyone have a guess as to why you need to spell out the accounts that you're going to access in a transaction? Yeah. What's that? Multiple what? Multiple wallets? Not quite.
What was the Solana uses proof of history, and so they have to keep a lot of explanation on holders.
That's not quite it either. Okay, we're close. We're close. So it has to do with optimizations. So he was mentioning proof of history. That's one of Solana's optimizations that we probably won't touch on too much today. But one of the great things that Solana does is it can parallelize transactions, right? So part of the reason for higher throughput, faster transaction execution is that instead of doing one transaction at a time, we can run multiple transactions as long as they don't write to the same account at the same time, okay? So basically, every time you do a transaction, submit a transaction, you include an array of all the accounts that you're going to read from and write to, so that the network can intelligently say, these two transactions can't be run at the same time, because we'll have some race conditions where they're writing to the same account, whereas these, X number of transactions can run at the same time, because they're accessing different accounts and we're not going to run into an issue. Does that make sense? So that'll be one of the things that we'll run into in a few minutes when we actually start building stuff, is like, okay, we got to remember what accounts to put into this transaction, right? On top of that, the transaction has one or more instructions. We'll talk about instructions in just a second. It's kind of the building block of this whole thing. Transaction also needs a recent block hash, and that's more for what you were talking about with proof of history. And then it needs one or more signatures. Okay, so a signer on the account that can sort of validate that it comes from a certain address. Okay. Now the fortunate thing is those last two, the block hash and a signer, those tend to be taken care of by whatever library you're using. Okay, so you don't have to figure out what the recent block hash is and add it in there. The Web3 library is going to take care of that for you. Let's talk instructions for a second. As the name suggests, instructions contain information required to tell the network what to do. Right? So you're submitting this transaction because you want to call a program. So the instruction tells you what program you want to call, right? So an identifier to the program it intends to invoke. Again, another array of all the accounts that it intends to read from and write to. Okay, so it's kind of duplicating that there. But again, it's also the network can be more optimized under the hood. And then lastly, you can include data as a byte array. This is going to be the trickiest part, because instead of you calling a function like you would in JavaScript, where you can pass it parameters, right? Say this takes 3 parameters. I'm going to pass it, a number is the first parameter, a string is the next parameter, a number is the last one. Instead, you got to package that up into a byte array, right? This is the piece that scares some people. It's not as bad as it sounds. We'll make it work, I promise. Okay. Here's an example of creating a transaction. So I can show first real quick.
Sorry, but what is the reason why
Yeah.
Why is packaging library why?
As opposed to calling yeah. So think about a REST API, for example, where with a REST API, if you're doing like an HTTP post, you might include parameters either in the URL itself or in the body of the REST API, and you're using what are effectively effectively unnecessary bytes to put JSON there, for example, to spell out your parameters. Whereas here, it's very optimized, and you're just saying this is the data that we're passing through, and we're going to anticipate the structure of the byte array that the program is expecting, and we're going to package it up as small and cleanly as it can. Does that make sense?
Optimization.
Yeah, it's all for optimization. I think we all are, I don't know, it's probably been a couple decades since most developers have to worry about optimization, right? Like we've lived for so long in this plethora of speed and memory and that sort of thing that we don't really think about it. But it's a whole different ballgame when we're dealing with blockchain stuff, which I think is probably good. It makes us more rigorous with what we're doing. Great question. Okay, gonna jump in here real fast. So here's an example, again in TypeScript, of creating a transaction. This is with the Web3 library. So you just use the constructor to create a new transaction. And then you have to create an instruction. I started with one of the easier examples where this is, instead of this being kind of a custom instruction, this is the instruction for sending SOL, which is, since it's kind of a standard thing that people do a lot, there is a helper function in the Web3 library for doing that. And then you add the instruction to the transaction. And then you call send and confirm transaction. And you pass a couple of parameters that we'll focus on later. So we don't need to get too, we don't really know exactly what every one of these lines is, but this is sort of the general layout of creating and sending a transaction. Cool? Any questions about this? Awesome. All right. So, sort of following up on the question about byte arrays, why we do it, or rather, how we do it. We need to talk about BORCH serialization. So BORCH stands for binary object representation, serialization for hashing, which is a mouthful, so we just say BORCH. Plus its full name, so we just say BORCH, right? So basically, when you're packaging up your data for an instruction, you need to make sure that that byte array matches what the program is expecting. Okay? So what that means is the data needs to be in the right order. Each segment of data needs to be the right size, etc. So it becomes very helpful to have a specific protocol for how you're going to take data in like JavaScript, for example, and turn it into a byte array. Enter BORCH, which is basically a protocol that prioritizes speed and security for serializing data. And you can read about it on their website. I think it's like borch.io or something. But the general idea here is, hey, we've got this JavaScript object. We need to turn it into a byte array that works. And we use BORCH. And again, there's a library for that. We're going to use project serum/BORCH. But this is an example of how we do that. So again, I'll kind of put my cursor over here and show you. If you're using BORCH, first thing you do is create a schema or a layout, right? And this is basically, this is a BORCH representation of what your byte array is going to contain. So in this example, we have like let's assume you have like a player object where the player has inventory, they hold an item. So we've got this player ID and this item ID that we need to package up in a byte array. This variant, by the way, would not be related to the player. This is something that sometimes people do if there's multiple functions on a program. This variant would just be a number, sometimes a string, that identifies which function on the program you want to access. Okay? So you basically come here and you say what type each of these is. So we're going to say we want to send a BORCH, we want to send a byte array that represents a struct that has properties for the variant, player ID, item ID, where they're an unsigned 8-bit integer, an unsigned 16-bit integer, and an unsigned 256-bit integer, respectively. Okay. Order does matter here. The order you put this in is the order that the data will actually get put into the byte array. So if you swap the order on this relative to what the program is expecting, the program might be expecting variant first, and if you put player ID first, well, you might get an ID that doesn't match a variant, or probably worse, does match a variant, but it's not what you're expecting. Right? So order matters. And then you create a buffer, and then you use the encode function on that layout to put actual data into that buffer. Again, don't worry about memorizing this or understanding it completely. We're going to practice it together again in just a few minutes. But you encode real data, this object right here, into the buffer. And then the last thing I do is just slice off the tail end of the buffer that isn't actually being used. Okay? You could, arguably should, build a method that does a lot of this type of thing for you, right? That slices the buffer for you, that sort of thing. But this is kind of general idea of how it works. Questions? Feeling good? Yeah? I'm getting some head nods and some blank stares.
So functions are only for Solana or for Web3 types. It's like the library.
Sorry, repeat that. The function here. So these functions are from Porsche. Okay.
And the last one, so the previous.
This one, these functions come from the Web3 JS library. And like I said, we'll do this together. So if you're following along, you'll have to import the right library and refer to it directly. Cool.
James, can you talk about lab ports?
Yeah, sure. So lamp ports is fractional sol. So it's what is it?
9 decimals.
9.1 billion.
Yeah.
Yeah, 1/1000th of a sol. So it's fairly typical, I think, for most native tokens of a blockchain to have like a fractional version of that token. And so lamp ports is kind of the default. So probably every function where you're putting the amount of sol, you're actually putting the amount of lamp ports. So you need to be like, I'm going to send 2 sol. Well, 2 times 10 to the 9th. That's how much, right? So this lamp ports per sol constant up there is cursor. This one right here. That's given to you by the Web3 library, so that you don't have to have added numbers scattered throughout your code. Cool. Any other questions? No. Okay. Then let's build some stuff then, shall we? Does anyone need that link again before we jump in?
Yeah.
To the repo? Okay. I'll give just a couple minutes for people to download this again before we get started. What I would recommend, if you want to follow along, and I encourage you to follow along, is to open up the repo that you downloaded, get whatever setup is most comfortable for you. Go ahead and do an npm install if you haven't already, because you will need to do that at some point to be able to run the project.
I'm going to drop the repo in Discord as well.
Yeah, that's great. I didn't even know we had a Discord for me to. We should have done that in the first place. Thank you.
Yeah, it's in the general chat.
Cool. So just to make sure everyone heard, if you need the repo, you also drop the link in the general channel in the Discord. So go ahead and grab that if you need it. And again, go ahead and do an npm install once you've got it, just to make sure we're ready to go. If you're running into any dependency issues or problems with the repo, if it just doesn't work out of the box for you, and it very well might not work out of the box for you. If you've done this kind of thing before, if it's not your first rodeo, you know that sometimes that can happen, right? The version of like Node that I have on my computer might not be what you have. If you're running into any issues, just watch, right? Just watch and soak up the concepts instead of trying to follow along. It's not the end of the world, right? This will be recorded. Go back and look at it afterward. Again, it's also part of the course that we have available online for free, so you can go look at all this content later as well. Repetition of content is good for learning, in my opinion. All right, we get like 30 more seconds before we get started. All right, let's get this started. Is that okay for everyone size-wise? Size of the text. Assume yes. Okay, let's talk about this project. let's do a quick overview of the project itself. It's a simple Next.js app. Okay, if you're not familiar with Next.js, it's basically just an abstraction on top of React. Makes a lot of it cleaner, in my opinion. I'm a fan. And then I use some stock components from Shocker UI because, like I mentioned before, I'm not a front-end dev. I don't want to have to worry about the CSS directly if I don't have to. All right, let's run this real fast. I'm going to do npm run dev in the console, and then I'm going to open up the project in here. There we go. So this is what it looks like when it's running. All right. Quick note: everything, the reviews that are shown here at the bottom, this is mock data. Okay. So in a perfect world, right, we would build this out to where we can submit a movie review right here. So movie, the best movie in the world. And then give it a review and hit submit, and it would submit a transaction for us, right? And then we would also be fetching the actual accounts and displaying movie reviews from everybody down there, okay? Just mock data for now. We're only going to work through that first part of submitting a transaction, okay? Again, the rest of this is in the course, so if you want to go jump in the course and keep going through the rest of it, I am all for that. Now notice I hit submit review, it didn't do anything, and that's because we haven't built that part yet. It does, however, log to the console down here, the object, so it's got the title, it's got a rating, it's got a description. All right? Just a quick overview of what this is doing. So let's jump back into the project itself, and let's look at some of the code. A couple of things to note in app.tsx. You'll notice that we're using this wallet context provider. That is a Solana thing that we're not going to work through together, but I just want to quickly go through at a high level so that you know what it's doing. That's a component up here in the components directory, wallet context provider. That's basically using a bunch of providers. It's amalgamating a bunch of providers from Solana's wallet adapter libraries. So we're not going to cover wallet adapter stuff today more than we have to, but that's basically what allows us to interact with, connect to the wallet extensions, all right? So like here, for example, when we're connecting to a wallet, we do that, we can do that because of the wallet adapter libraries that Solana provides. It makes it easier to do that, and it makes it possible to support a wide range of wallets without having to configure that support on your own every time. The other things we should note is we have this movie object. So movie.ts in the models directory. We've just got this class that has a title, a rating, and description, which should sound familiar since just a minute ago I pointed out the object that was logged to the console that had a title, a rating, and description. Basically what we're doing here is when the user clicks submit, we're creating a movie object, and right now we're just logging into the console. We're going to take it a step or two further. All right, and then like I said, we're using mocks right now for that list, so I've got some mocks here. And then lastly, the thing I want to talk about is form.tsx. So if you jump in there, you'll notice we've just got a functional component that displays some stuff as a form, and on submit, like I said, it creates this. Oh, we lost our sharing screen. That's unfortunate. Give me a second to get that back. And we're back, right? Okay, great. Cool. So we create the movie object, and then just for the sake of having all of our Web3 stuff in one function on its own, I have this handle transaction submit function on line 19, right? Where it just logs the movie object on line 20. We're going to replace line 20 with all the other things. Okay? Everybody good so far? Got a general handle on the project? Awesome. All right, let's jump in and actually write some code. So we're going to start with the movie class. And the first thing we're going to do is that Borscht stuff that we talked about. Okay, so we have a TypeScript object, and we need to create a schema or a layout for Borscht that represents that object. Okay, so what we're going to do is we're going to jump in here. I'm just going to add a couple lines, and I'm going to add a property for Borscht instruction layout. And it's going to yell at me immediately because I haven't imported Borscht. So I'm going to delete that, and we're going to import Borscht. So I'm going to go to the top of the file and import Borscht from project serum Borscht. Okay. So this is my preferred way of doing it. Yeah, what's up?
You know the security key to the web?
It's
activate
yeah, activate wormhole all lowercase. Cool. All right. So now that we've imported Borscht, now I can do this and have it actually work. So Borscht instruction layout equals Borscht.struct. This constructor takes an array. I'm just going to pop it into the array in there for now. Leave it just like that. And we're going to talk about what we're trying to put into this. Okay. So what are we trying to serialize? What are we trying to encode? Hit me with it. What?
Schema.
We're creating a schema. Yeah. And what does that schema represent? What is it going to represent here in this project? What's that?
The account data.
Not quite.
Transaction.
So this is a schema for our movie object. Okay, we're gonna take what is our TypeScript movie object and convert it into this byte array. Does that make sense? So what's that?
Besides the accounts.
Yeah, we'll get to the accounts. That
I said besides the accounts.
yeah, it's the data. Yeah, exactly. When we're creating a transaction, we'll get to the accounts array. But for now, we're creating the data bit, the custom data bit that's going to go into the instruction. Okay. So we need to take this custom object and turn it into something that works with Borscht. So we're going to take each property of the object individually. Does that make sense? So what do we have on the object? Well, we've got a title, a rating, and description. So I'm just going to start by saying, putting in comments that we need those things. Cool. So these are the things that we need to get into this Borscht schema. Now on top of that, there's a couple of extra things here, which is we can't actually know the schema based on our JavaScript code or our TypeScript code. Why not? What defines the schema for us? Anyone? The program, right? We're going to be calling, when we submit a transaction, we're calling a program. When you call a function in any of your code, what defines the arguments you're passing into the function? The function you're calling, right? So we're calling a program. The thing that defines our schema is the program we're calling. So at this point, you've got a few options. You either wrote the program yourself and happen to know the schema off the top of your head, a la me in this scenario, right? You're working with another developer who wrote the program, and they can tell you what the schema is. It's an open source project with documentation. You can read the documentation, or you reverse engineer some code and you figure it out. Okay, those are pretty much your options. In this scenario, I wrote the program. I can tell you what it's expecting. it is expecting exactly what we put right here, plus a property that's a variant, and it is expecting it in this order. Okay, so it's expecting variant, title, rating, description in that order. Right? Variant, it's expecting as a number. Title, it's expecting as a string. Rating, it's expecting a number. And description, it's expecting a string. So now that we know all that, we can fill out this for struct. But instead of doing it for you right in front of you, I'm going to give you 60 seconds to do it on your own while I display this example. Just as like a small, like, sorry, it's not showing up. It's slow in a second. Someday. It's not what my computer looks like. There we go. That's what my computer looks like. So with this example being displayed, okay, give you 60 seconds to try to do this on your own. So same idea, different specifics. Yes,
I have a question. Why do you use 3 different types of unsigned integers for the schema?
that's a great question, because that's going to play into something I'm going to talk about in a second. Did you have an answer? I thought I heard someone say something. Yeah, so it just depends on what the program is expecting, right? So for example, variant in this scenario and in the scenario that we're working on right now represents essentially the function on the program that you want to call. So there's one entry point into the program, right? And if your program does more than one thing, then you probably need the very first thing in transaction instructions to tell you which thing it's supposed to do out of all the things that it does. And variant in this case represents that. But an unsigned 8-bit integer gives you what, 250? Yeah, 256, I think, which is plenty for a function. You don't need a bigger integer than that to decide which things to do. So there, it's going to use an unsigned 8-bit integer. Whereas different types of IDs might need different things. So maybe your program knows that you're not going to have more than 10 or 15,000 players, in which case a 16-bit unsigned integer is fine for a player ID. But maybe you're going to have hundreds of thousands of items, and so you want to get ahead of that and make sure that there's enough room for it. Cool. All right, great. That is a great question because it plays into what we're going to do here. If I can get my computer to work with Zoom. Currently, I cannot. There we go. Got it. All right. So now you had a chance to do that on your own. Let's do it together. We're going to do a variant, and so we do borscht.u8. We call it variant. Then we're going to do the title. That's borscht.str. Then we do the rating, which is also an unsigned 8-bit integer. So I don't know why it's string. And lastly, description as a string. All right. So again, this is just something you know because I said this is how the program works, right? Just like reading documentation for an API, and you have to make your web calls match that API. All right. So variant and rating are unsigned 8-bit integers because variant, I think this program has 2 variants, so definitely don't need more than an 8-bit integer. And by the way, borscht doesn't go smaller than 8 bits. Does that make sense? So it works in 1 byte increments, so 8-bit increments. And then string, which is dynamic, and borscht does some fancy things where the first 4 bytes, I think, are allocated to telling you how large the string is so that you can decode it, that sort of thing. And then rating, again, it's just a 1 through 5, so 8 bits, plenty of space, and then a string again. Okay? Any questions on this? Yep. The first item, the variant. Yeah, so in this case, the variant is saying, hey, I know this program has 2 functions, and I want you to do the first function. Yeah, so we're gonna end up passing it 0, because that's what this program is expecting for the function we want it to perform. Yeah.
What happens if I guess you use like a bit that's like higher than what's needed? Does it affect like GPS like program or like how much of data? Like what would be the response?
Yeah, so it probably doesn't matter for small things, but it probably would start to matter the more your program is used.
For something that's like very high.
Yeah. Yeah, and it would matter if there's a mismatch between the program and your client side code. That makes sense?
Yeah.
Cool. All right, so now that we have this layout, let's create a function that will use this layout and the object itself to give us a byte, an actual byte array. Because that's the thing we actually want. We want a byte array. And man, the internet here is just beautiful, right?
It's part of the challenge.
It's, yeah, this is,
We're being tested.
I don't know if anyone has done live coding before, but this just makes it that much better. Almost there, maybe.
Yes.
Yeah. That's good. Let's talk. While we're waiting for this to catch up. If you don't what? Yeah, so if they're incorrect, you'll get an error on the program side when trying to decode the information. So if the program says, hey, I know that the first byte, the first 8 bits, is always gonna be an integer that I can use to determine the variant, but then instead, what it sees, how do I phrase this? If instead you put a string there, for example, the first 4 bytes are going to tell you the size of the string, but the program doesn't know that. So the program is just going to say, yeah, I'm going to look at the first 8 bits, and it's probably going to be 0 unless you have a really long string, right? Because the first 8 bytes is such that like the actual description of your string length is coming at the end. So it's actually just probably going to see 0, and you'll just get undefined data. That makes sense? Yeah. This is the more low-level stuff that I was talking about. Okay. Let's jump into finishing this up. So we're going to make a function called serialize that's going to return a buffer. Okay, a buffer is our byte array in this case, right? So all we need to do in this is create an empty buffer and then use the layout that we just created to encode some real data into that buffer, right? So I'm just going to say const buffer equals buffer.alloc, and I'm going to pass it 1,000, because that's going to give us a byte array that's 1,000 bytes long, and I think that's more than enough for what we're about to do. Okay, you could decide that you want to allow really long movie reviews, and maybe you need to put in 10,000 or 20,000. But in this case, we could just cap the, like Twitter type thing, 280 characters, and you're done. Right? And then we're going to take that buffer and our instruction layout that we created, and we're going to say dot encode, and then we're going to pass in an object with the actual stuff that we want to encode. Okay? And that object happens to be this. So because this is a method on the movie class, I don't know how familiar you are with TypeScript or types. Because this is an object on the movie class, we can use the spread operator here and just say dot 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 this, and then add the variant bit afterward. Whoops, I lost the curly brace, sorry. And for the sake of readability, I'm going to space this out a bit, and then we pass in the buffer. Okay, there's quite a bit of lag here. So we'll give it a second to catch up. Yeah, so all this is doing, this this is basically saying this is a method on an instance of movie. So to call this, you have to already have a movie object that has concrete values for title, rating, description. And when you use the this inside of an object, it's taking the existing values and putting it into this new object. So we're creating a new object that has all of the title, rating, description from the movie that we're part of, and then adding variants to it. Okay. And then just because the encode method, it needs the values as an object, and then it needs the buffer. So we're putting in a buffer. And then lastly, we're going to return the buffer, but we're going to slice it so that we don't have the extra bytes at the end that we're not using. So we're going to slice it from index 0 to this dot portion instruction layout dot get span, passing in the buffer. Get span basically just says, hey, what's the last index at which this buffer is actually being used, right? So once we get to the end of our portion coding, it's saying, we're saying, okay, everything after that, we don't need that anymore because we made a buffer of arbitrary length. We just decided it out. We don't actually need 1,000 bytes. Cool? Questions so far? Awesome. So that's everything on our movie object. And we're done with basically getting our data in the format that we need it to send an instruction. So let's jump over to form.tsx and let's actually build our transaction with our instruction, with our custom data. Okay? And if you have questions throughout, just shout them out, get my attention somehow, and we'll figure it out. All right, so the very first thing we need to do here is we're going to end up using that Web3 library we talked about. So I'm going to go to the top and I'm going to import that. And you can import just the methods and the types you're going to use, or you can just import all of it. That's my preference. It's Solana/web3.js. That. There we go. I love the delay. I can write it and watch it happen, just like you guys. And then we're also going to need to use a couple of React hooks that come from the wallet adapter libraries that I talked about a little bit earlier. We're not going to do it, I'm not going to dive into what they are, how they work, that sort of thing, but they provide some React hooks that are going to help us. So I'm going to import use connection and use wallet from, this is Solana/wallet adapter React. Or if I can spell. There we go. So use connection and use wallet from Solana wallet adapter React. Cool. So we're going to use all three of these things. So I just want to get them imported, ready to go. So now if we scroll down, we're going to need from use connection, we're going to need a connection. We're going to need a public key, and we're going to need send transaction. I'll talk about what each of those do as we go through, but I'm going to go here just underneath the use states, and I'm going to say const, and then use get connection from use connection, and there we go. That came up quick. That was great. So we're going to yes, scroll on top. So that is wallet, Solana wallet adapter React. Good. Okay. So what do you guys think connection is here? Anyone want to make a guess? Yeah. It's connection to the chain, basically. Yeah. So it's a connection through the Json Rpc to a cluster. But I'm going to dive into that too much, but a cluster is like our dev net versus our main net, that sort, or local host if we're using a local, test cluster, right? Test validated. So, this is our connection, and this connection is going to be based on what is in the user's wallet. Okay, so like we're going to jump in and we're going to change our wallet from mainnet to devnet because this program only exists on devnet. But that's what the connection is. You don't have to worry about it too much. Just know you have to have it. And then we're going to get public key and use send transaction. Sorry. And that's all coming from use wallet. So public key and send transaction. Use wallet. There we go. So what's the public key here? What do you think? What's that?
The wallet.
Yeah, the user's wallet address. Exactly. Okay. Only if you hover over it, it'll tell you it's of type web3.public key. So it's not just the string, right? The string is sort of the representation we're most common with, but there's an actual type for it. Okay. And then send transaction. Well, that's the function that we're going to use to send the transaction to the wallet for approval. Cool. So we're going to build the transaction. And we're going to say send transaction, pass it the transaction, and then let the user decide if they want to submit it or not. With that, we can jump down to line 25 here, the console log inside handle transaction submit. We can get rid of it and we can start building our stuff. We can start creating our transaction. Okay. The very first thing I like to do is do a quick check to see if public key exists, and if it doesn't, to return. Because if there's no public key, when would there not be a public key? User's wallet isn't connected, right? So if the user's wallet is connected, this public key will be available to us. If the user's wallet is not connected, there won't be a public key, and well, I'm not submitting a transaction if I don't have a public key to submit, right? So I always start with that. There's probably other ways you can do that are smarter, but that's my one. All right, next thing, we have a movie object, right? There's a movie object passed in on line 24, passed into this function. And we have a method on movie object that will give us a byte array, right? We created that method. So we can say const data equals movie.serialize. And if you hover over data, you'll notice it is a buffer, which is exactly the type that we need for the custom instruction data. Once we have that, we can actually create our transaction. And that's just a constructor in the Web3 library. So web3.transaction. Boom, new transaction. Transaction doesn't do anything yet. We need to add instructions to it, right? So let's create an instruction. Instruction equals new web3.transaction instruction. And again, that's just a constructor that it provides us. Only it actually it requires an object that spells out all the stuff we talked about earlier. That stuff we talked about earlier being the program ID that you want to call, the data you want to pass along, and the array of accounts that will be read from and written to. Okay, so we need all three things. So program ID, leave it blank for now. Data, that one's easy, we have data. And then keys is the name of the next one where we're going to put the keys in there. We're going to get some errors because I didn't actually put a program ID in yet. If you scroll up, you'll notice there is a program ID already in the starter code for you as a constant. Okay? If you type that out, you'll get an error. So it says type string is not assignable to type public key. So remember, I said just a minute ago that that string representation of an address or an account is not what it's expecting. It's expecting an actual type. So we can fix this by just putting new web3.public key and wrap the movie review program ID in it, and then it will work like that. Right? Any questions so far? Things are about to get wild. Yeah.
Which Web3 library?
This is that web, so Solana/web3.js. We did 2 imports. This on line 4 and 5. We did both those imports in this file. Cool. If you have questions so far, now is the time to ask because we're about to do something gnarly. By gnarly, I mean fun, obviously. Okay, so the last thing we need to do here for the instruction is provide the array of accounts that we're going to read from and write to. Okay? Do you know what accounts are going to be read from during this transaction? Right now. Do you? You shouldn't, because I haven't told you that, right? But how would you know? How, remember before when we were talking about the Gorsh layout, what defines the schema of your byte array for the custom data? The program you're calling, right? So similarly, what defines the accounts that will be read from and written to during this transaction? Well, the program we're calling, right? So we need to know the behavior of the program we're calling. So unlike unlike a REST API where you don't need to know anything about the implementation of the API behind the scenes, you just read the documentation and you're like, I give it X, it gives me Y, and it's a good day, right? Like in this scenario, you need to know the implementation details of the program. So in this case, I happen to know those. I'll continue to give them to you as I have so far. We have the user's public key. So the user's account that will be read from, not written to. Then we have, I'm going to call it super special account for storing the review, right? So we're sending a review to the program, and the program needs to store that somewhere. And we're going to talk about that in a second. And then we have the system program, okay? The system program does a lot of different things. But in this case, the system program is going to be used to create the super special account for storing the review. Okay, so we will be reading from the user's account, we will be writing to the super special account, and we'll be reading from system program. Cool? So to dive in here, let's start with the user's public key, because that one seems easy, right? We already have the user's public key. Do we not? So if we put the public key here, we'll get an error because it's not expecting a public key, it's expecting an object of type account meta, which has a public key, a boolean for is signer, and a boolean for is writable. So we're going to do an object there instead. Say pub key is public key is signer, true is writable, false. So the is signer is basically saying, hey, this account right here is a signer on the transaction. And then the is writable is saying, is the program going to write to this account during the transaction execution, yes or no? And it will not. I can tell you for a fact the program will not, because it literally can't, for one. And two, because that's not how the program is designed. Okay. And then the last one, we can do the last one, the system program, because the Web3 library makes that available. So we pub key system program dot program ID. And then is signer? No, it is not a signer on the transaction. And is writable? No, it is not writable. Whoops, Web3 dot system program. That's what it's yelling at. Typos here. Bear with me. Cool. So we now have 2 of the 3 accounts. There's this last account. Okay, we need an address and a public key of the account where the data will be stored. So again, with a traditional Web 2 program, you send off some data to the API. You don't know what database it's storing it in, or even if it's storing it in a database, or if it's just a janky server where it's like writing files. We don't know, and we don't care. We just want it to work. Whereas in this scenario, we do need to know where it's storing the data because we need to know what account is being written to. So enter something called PDAs, which stands for Program Derived Address. Okay. I'm just going to write this, and you're going to watch. You're going to type it if you're following along. You're going to take my word for it that this works, and then we're going to talk about it. Okay. And this is really the last part of it. This is the end after that. So const PDA equals await web3.public key .find program address . There we go. That is our super special account, the PDA object that we captured there. Okay, this PDA right here. The way PDAs work, okay, is basically an account, a public key, is derived from the program ID itself, plus any number of seeds that you want to add. So there's an equation, the same equation that's used to generate your public and private key pairs, right? A similar equation is used to derive a new address based on the program's ID. But it's a special type of address that doesn't have a corresponding private key, which means only the program can sign for it. Does that make sense? So there's this really cool security piece, which is all accounts that are derived off of a program, they can't be signed for by anything but the program, which from a security perspective is kind of cool. Like we can go down like the nerd snipe rabbit hole about that, but we won't. We're just going to stick with that. But also it's cool because you can derive it deterministically. So if you know that the program is deriving that address using the user's public key as a seed and the title of the movie review as a seed, then you can derive the PDA's address. And that's perfectly safe and secure because you can't sign for it, right? It's just a public key so that you know where it's located. And so that's what we're doing here. So basically the movie program is saying it's effectively building a primary key for for this movie review based on the user's public key and the movie title. Pretty cool. And then we're going to add that here as pub key, PDA, is signer. No, it's not a signer. Is writable. Yeah. This is the only thing that's writable. That's the whole point of what we're doing here, right? Is to write to that account. Is to store the movie. Put a comment in there so it stops yelling at me. Okay. We've built our instruction. The very last thing you have to do is to add that instruction to the transaction, right? And then remember that send transaction function we got from the wallet adapter library? We're just going to call send transaction, pass it the transaction and the connection, and then it'll give back to us a signature, a transaction signature. And I'm just going to log that so that we can see it in the console and play around with it if we need to. Okay. So before I run this, this seems like a lot. If you've never done this before, it is objectively a lot, right? 2 months ago, I didn't know any Solana Web. None at all. And this is very second nature now. But just to the point where I'm standing in front of you, doing it live, and only like a little bit nervous, right? Which means it's not that bad. Okay, so do it a few times, and it'll be second nature, and you'll get it, and you can start to build your own abstractions that work for you that feel really good. Okay. That being said, let's run this. Doing my npm run dev. It's down here. There we go. And then I'm going to jump into my browser. I'm going to refresh that. I'm going to connect to my wallet. I'm going to not let you guys know my password. Connected to my wallet. Oh, wow, this is way behind. I'm already in. There we go. Connected to my wallet. Test movie 35. I don't actually know what number, but it can't collide with another one because of the program. So just throwing out random numbers here. And then random rating, submit review, and that should give me, oh, I probably didn't save my files. I didn't save my files. Make sure you save the changes in form and movie so that this will work. Okay, now I'm going to click submit review. And expect it to work even though it didn't. Hoping that's just a lag thing. Yep, that was a lag thing. There we go. Got a pop-up. Yes, sir.
I have a question. So when somebody comes and does a review, does the PDA change every time?
No, because the PDA is based on the movie title and the user's public key, which means it's a different PDA when you submit a movie review than for me. So you can think of the
Because
account.
of the wallet transaction?
Yeah, so it's looking at your public key and the title of the movie that you put in. And you can, in this case, we're using a count of a file where we're saying we're doing a new file for every movie review, where the name of the file effectively is an address based on your address and the name of the movie, right? So we have different files in this scenario. So cool. This is telling me that the transaction may fail to confirm. I don't know if that's real or if it's because the internet's jacked right now. So we're gonna just hit approve and see what happens. Okay, so I did get an error. Transaction simulation failed. That feels like a problem right now.
Is it because you're not indefinite?
What's that?
Is it because you're
I think I already switched to DevNet before this. Yeah, I'm currently on DevNet. What's that? Potentially. Yeah, even like getting the pop-up open is a struggle right now. So see if I can. Oh no. Now we lost that. Oh, come back. Okay, I changed my internet to my phone. And it doesn't say that this is going to fail. So I'm going to click approve. Hope for the best. Stuff like this there. Oh no, it worked here. It's right there. You guys still see it? Okay, so I got a transaction signature down there. So what I'm going to do is I'm going to go to explorer.solana.com. I'm going to change from mainnet to devnet as soon as stuff loads and works. And I'm going to prove to you that it worked. Just a second, because that's not the screen I'm on, so that's not doing great right now. Oh, what's that? I'm not there yet. It will be exciting in a second. Yeah. Okay, any questions while I'm just hoping this loads? Anyone else? Yeah.
So just out of curiosity, what's like the max bid that you said? Is there like a hard coded limit or just like?
There is a limit for a transaction. There's a limit on the transaction size itself. I don't know off the top of my head.
The maximum
Yeah,
transaction size?
yeah, I don't know what it is, but there is one. Yeah, I think it'll have to suffice knowing that there is one. You can look it up in the docs pretty easily. It's probably, there's a site, solanacookbook.com, that has a bunch of stuff, and it's probably on there pretty easily for you. This may never look.
Are there any cases where we store data in just arbitrary accounts, right? So is there a use case for storing data in like a user's account? Can you do that?
I don't think you can. I could be wrong. Or do you know if you can write to a user's account directly?
Use PGAs. Is it to store data?
Yeah. So he was just asking, like, can you write to a user's account specifically? I don't think so. So I know for a fact, because one of the things I tried, like, right out of the gates was to write to a program account directly. Can't do that, but it literally just doesn't work. I want to say it jacks with the program, but it doesn't usually. All right, you can see the screen now. Yay. So I tried to get on DevNet. I tried to paste the transaction signature. That'll load. Someone else had their hand raised. Someone else have a question? No? Okay. Well, this is loading. You're welcome to stick around and see. Oh, there we go. There we go. Okay, if you scroll down and look in the program logs, you'll see test movie 54. So we know we got data to DevNet to the right program because of the logs here. The next step would then be the fetching all of the accounts and displaying them in the UI. We're not going to do that. We've already passed the allotment of time where like people can stay focused, myself included. So we're not going to do that today. But I strongly encourage you to give it a shot. Despite the internet jacking with, like you said, the most exciting part and making it pretty anticlimactic, I think this is pretty cool stuff. The very fact that we can see this and it's not in a centralized database anywhere is just so freaking cool, right? I love that. Okay. So before we finish for real, are there any more questions? Okay, I'm happy to stick around as long as you need and chat about whatever you want. I'll also be here tomorrow to do something more on the program development side of things, less front-end focused. Yeah, thank you so much for being here. Again, just a reminder, when this pops up someday, the course is available at soldev.app/course. The solution code for what we just worked on, here's a link to it. It's also linked to in the README of the repo that you already downloaded. Okay, and then if you ever have questions when I'm not here, aka a couple days from now when I'm no longer here in Florida, you can hit me up on Twitter. I'm happy to answer questions or chat. Or just be friends. I mostly just use Twitter to hang out. So yeah, that's that. Thanks so much, guys. Oh, that's this is yeah, this is a great question. Anything we're touching the data that's very valuable because we're using